Okay, well, my name is Nadim Conti, and I'm here to share with you a vision. I think to solve a problem we are facing, I mean space launch starvation. And as you can see, this is launch, so mission control, launch time. We are set to launch in T-5, 4, 3, 2, 1. Well, wait a second. Aren't we missing something? I mean, by going into space the old way. Well, bear with me. We've been into space thousands of times since the 50s. Sometimes with small rockets, like this one, a sounding. Other with bigger ones, like this Pegasus that needed to be air-launched from an Airbus, I guess. But the question is, why, with all this technology, we are facing a launch starvation? You can see it here that right now, we are launching almost half of the rockets we were sending in the space race. And why is that? I mean, we can do it. Come on. Well, I think that one problem is that to launch big rockets, we need to build space pads near oceans, deserts, or basically Russia. Because big rockets are quite dangerous if something happens, you know, falling on people's head. And big rockets actually need huge infrastructures, like, well, maybe not like Kennedy Space Center and so on, but, well, you got the idea. And it is even worse if you're trying to do something complicated like this. But here there is another problem. We are in the information era, but how many people saw that? I mean, a first stage landing on a boat is amazing. I was like crying for that by the happiness. But the thing is, not many people saw that, and the few of them that actually enjoyed it, well, have that idea of maybe space control centers that are boring or far away, only for extravagant people like Sheldon Cooper from Big Bang Theory, if you got it. But, well, we might have a solution. In 1999, the CubeSat era began. Stanford Research founded this standard of small satellites able to be developed in small laboratories like Polytechnicos one or whatever you want, basically. And what are they? Well, they are just little cubes, 10 centimeters per side, 1 kilogram at most of weight, and they can be developed and launched cheaply, well, most of. And they can be used for a lot of many different applications, like developing new thrust things, light sails, or little telescopes. But we are still missing something, like $17.1 million. No, this is for an example. These are the money awarded from NASA a few years ago through 3 companies to build rockets able to lift the CubeSats. One of them is the Electron rocket. But the problem here is that even if those rockets can lift hundreds of CubeSats, they're huge, and they are based in USA or New Zealand, so nothing from Europe. And you need basically a 747, like a Virgin proposal, or a huge pads to launch them. So I think we are still missing something. Here's the idea. Why don't we take the step-down approach that we used for small satellites, converting from huge satellites like Hubble to small CubeSat on the rocket side? I mean, we can study and think about new ways of developing rockets, smaller ones that can launch only a few of CubeSat, and can be developed in an open mindset way with an open source community. And hopefully, one day, with this idea in mind, we can finally launch again rockets into space from Europe, sparking ideas from our students and our enthusiasts. So in my mind, this is an idea worth sharing, and I hope so. Dream small. Thank you.